We are going to start on activity 10 in our science book. And activity 10, oh, we don't want that. That's giving you all the answers. Activity 10 is talking about the properties of mixtures, okay? And I do want to go and let's review mixtures real quick. So let me open up my glossary and I'll search for mixtures because we haven't talked about mixtures a lot lately. Is there anybody who can remind me what a mixture is, or at least what they think a mixture is?
A mixture is
a combination of two or more things.
Combination of two or more things, okay. What else do we know about mixtures?
It can be any it can be in any type of form.
And it doesn't change the properties, it still stays the same.
Oh, I like that. Yep, they don't change properties, they still stay the same. Yep. So let's review this little video here on mixtures. Remember, this is the one without sound. It says, have you ever made a salad? First you chop up vegetables. Some of them could be lettuce, tomatoes, cucumbers, and onions. Then you toss them together in a bowl. You've just made a mixture. A mixture is a combination of different things, but each thing stays the same. Now, if you do not like the onions, you can pick them out of your salad because it's a mixture. And the video is also showing us how to make a mixture or make a salad dressing that's a mixture. And there are those two different types of mixtures, heterogeneous and homogeneous mixtures. All right, there is the one video. Let's watch this other one real quick. This is the one that has words. So it's formed when two elements are combined and the properties of each element remain unchanged.
We know that when a compound is made from two or more different elements, the new compound is different than the individual elements. But when the elements combine, they do not always form new compounds. For example, let's make vegetable soup. To create our soup, we will put in some carrots, some peas, some macaroni, some tomatoes, some potatoes, and some water. This vegetable soup is a mixture. A mixture is matter made up of two or more different substances. But the substances in the mixture do not change. In other words, this piece of tomato is still a tomato. And this pea is still a pea. Another example of a mixture are these different types of rocks mixed together. And the gases found in the air around us make up a mixture. But neither the rocks nor the gases form new compounds.
All right, so mixtures, that's just a reminder of what mixtures are, because this activity 10, which again is in concept 1.2, activity 10 has you to think about which of these properties a mixture has, and you need to pick all of them that are correct. It's not just one, there's more than one. And then down below, you're going to provide some examples that support your answer to this one. So if you said that, let's see, that they can be liquids, solids, or gases, you're going to give me some examples of mixtures that are liquids, solids, and gases. And if you guys forget and you want to look up what a mixture is again, you can always go to the glossary and you can watch that again to help you out. So activity 10 is one of them. That's just kind of a review from what we've been doing. But then we're also going to move on to activity 11. So again, you should have my screen up, not your own. And we are going to look at this activity 11 and read through this together. So Morgan, do you want to start reading for me?
Matter can be changed physically or chemically. A physical change affects only the physical properties of a substance. It does not change the substance's chemical identity or produce new kinds of substances. Shaping a piece of clay into a ball is a physical change. The clay is still clay after you change its shape. Freezing and boiling water are both physical changes. Ice is water in its frozen or solid state. Water vapor is water in its gas state. Sugar dissolving into water is also a physical change. The sugar molecules spread out through the water molecules, but the sugar is still sugar, and the water is still water. Most physical changes can be reversed easily. For example, if you heat sugar water, the water will evaporate into a gas, while the sugar will remain a solid.
Awesome. So physical changes don't change the things, the actual elements, the actual properties. It's still the same thing. It just might look different or be in a different state. Okay. Hazel, thank you. You may read.
A chemical change produces a new kind of substance. The new substance is different physically from the original substance. However, it also has different chemical properties. For example, the elements iron and oxygen combined form rust. Rust is a flaky reddish chemical called iron oxide. When oxygen combines with carbon and hydrogen, however, they release heat and can start a fire. The fire can change a substance such as wood into ash. Unlike physical changes, chemical changes are not reversed easily.
Good. So then we have our chemical changes, which are changes that can't be changed back. For example, we had the two elements, we had iron and we had oxygen, but when we mixed those two things together, we created rust, something totally new, totally different from the iron and oxygen that we started with. Or if you mix fire with wood, then you create ash. Again, something totally different from what we started with, and you can't change that ash back into wood. Okay,
Don't you make ash regardless of what you burn?
I'm sorry, what was that?
Don't you make ash regardless?
Images was submerged in the pond. Inside the
You keep
cauldron
cutting out, I keep losing you.
So while Google Maps didn't save his life, it did save his family from having to wonder about what happened to him.
Nikita, I'm gonna mute you. You've got something in the background there. Emily, I see your hand is up. Okay. Oh, go ahead, Emily.
I said that was for reading.
I can't hear you. Okay, moving on, we have our picture here. It says if it's cold enough for a long period of time, even a large river can freeze over. How deep the ice gets depends on the river's current and the length of the cold snap. Is this a physical change or is this a chemical change? A river freezing over. Is a river freezing over a chemical change or a physical change?
Physical.
Physical change, you're right, because when it warms up, it's going to go back to being the river again, right? Back to just being liquid water, okay? So we have our physical and chemical changes. The first part, what physical changes were described in the text. So up here, it talked about clay, it talked about sugar dissolving in water, okay? So you're going to go through and you're going to list the physical changes that it talked about. And then down below, you're going to list the chemical changes that were discussed. So you're just doing those two activities in science. Let's take out our planners and write down our plan for the rest of the day. You guys see my planner?
Yes.
Excellent. So we have science, concept 1.2, activities 10 and 11. And I did assign these to you, so they should be at the top of science when you log into Science through Clever. And then your last thing to do is to silently read or independently read for 30 minutes. And that's it for the day. Remember, we'll talk about our book report tomorrow. So if you did pick up your stuff, please don't start working on that paper yet until I've had a chance to go through it and explain it to you. And